Good morning, all of you. Welcome to C. Jayendra Science Zone. Now we are discussing metallurgy chapter. The last topic in metallurgy, some important questions based on metallurgy. So already explanation part of metallurgy is completed. Now in this session, we are going to discuss all the questions related to entire chapter, and then we'll do summary of the chapter. So these questions are very important with the examples we have given with options. So please listen carefully, and then we'll end up this chapter by the end of this session. Now, let us start now. So now we are going to do additional questions in the entire chapter of metallurgy. So first one, in the electrolysis of alumina, it is mixed with cryolite. Mixed with cryolite, Na3Al F6 and fluorspar CaF2 in the ratio 20:40:20. The function of cryolite and fluorspar is to dissolve alumina, to increase the fusion temperature of alumina, and to increase the ionization of alumina, and to decrease the fusion temperature of alumina, and to make it good conductor of electricity. So since we know in the electrolysis of alumina, we'll add cryolite and fluorspar for what purpose? To decrease the fusion temperature, because aluminum melts at a temperature of 2000 degrees C. At this position, it is difficult to conduct electricity for alumina. So for this, what is added? For this, if you add cryolite and fluorspar, when cryolite and fluorspar is added, so melting point of alumina is 2000 degrees C. So if you add cryolite and fluorspar, then the fusion temperature will come to fluorspar, then the fusion temperature will come to 900 degrees C. So at the melting point of alumina is being decreased, that is fusion point. So answer is to decrease the fusion temperature of alumina and to make it good conductor of electricity. So option is D. Option D is the answer. So this question is very, very important. So many times they have asked, so why cryolite and fluorspar is added to alumina in the electrolytic reduction of alumina? It is to decrease the fusion temperature of alumina and to make it good conductor of electricity, to increase the conductivity and to decrease the fusion temperature of alumina. The fusion temperature of alumina is 2000 degrees C. So when these two are added, it comes to 900 degrees C. So at this position, it is easy to reduce aluminum oxide to give aluminium. So we'll add cryolite and fluorspar. This we have discussed already in the objective. I hope it is clear. Next question. Silica is added to roasted copper. Silica is added to roasted copper ore during smelting in order to remove cuprous oxide, cuprous sulfate, ferrous sulfate, ferrous oxide. So why silicon dioxide is added to roasted copper? So during smelting in order to remove ferrous oxide, because it forms silicon dioxide combines with ferrous oxide and form FeSiO3. This is called slag. This is called what? Slag. So slag is removed. So silicon dioxide combines with FeO to form ferrous silicate. That is nothing but slag. It is removed. So it is called as flux, and this is called gain. Since this is basic impurity, we are adding acidic flux. So silicon dioxide is acidic flux. So for removing basic impurities, we'll add what? Acidic flux. Next continuation. Extraction of lead from galena involves roasting followed by self-reduction, roasting followed by electrolytic reduction, calcination followed by aluminothermite, and hydrometallurgy. So lead from galena. What is galena? Galena is lead sulfide. Lead sulfide is nothing but what? Definitely will do roasting followed by self-reduction. So answer for this is roasting followed by electrolytic reduction, roasting followed by self-reduction, calcination followed by aluminothermite process, and hydrometallurgy. So answer is roasting followed by self-reduction, because galena is lead sulfide, PBS. Next question number 4. Fractional crystallization forms the base of which process? Zone refining, vapor phase refining, walling, and liquefaction. So already I have told you in the explanation of lecture, fractional crystallization is nothing but Zone refining. It is nothing but what? Zone refining. So answer is what? Zone refining. Zone refining is also called as fractional crystallization. Next continuation. Silver metal is refined by silver metal is refined by liquefaction, Pauling, Van Alken method, and cupellation. So it is nothing but what? Cupellation. Silver metal is always refined by cupellation. You can check the answer now. So it is nothing but what is cupellation method? As we already know, cupellation is a process in which it is nothing but a process of refining the metal. Nothing but a process of refining the metal. So once again, I repeat what is cupellation. Just you can remember easily. So cupellation is the process of refining the metals. Refining the metals. That is called cupellation. And so quenching, annealing, cupellation, etc. All these are coming under refining methods. Yes. Easily oxidizable impurities of other metals are removed. In this method, what happens? What is cupellation? Easily oxidized, easily oxidized, oxidizable or oxidizable, better write oxidizable, easily oxidizable impurities of other metals are removed. Impurities of other metals are removed in this process. Easily oxidizable impurities of other metals are removed in this process. The impurity of lead present in silver is removed as litharge. As I told you, the lead is removed. Lead is converted into lead oxide in silver. In silver, lead is present. So it is can be removed by the means of lead oxide that is called litharge. So this is called cupellation. This is called what? Cupellation. Next continuation. So in silver, what happens? Lead is present as an impurity. Lead is present as an impurity. So the lead is being easily, lead is nothing but it is easily oxidizable. So lead is converted into litharge, that is lead oxide, and is removed in this process. So silver is being purified. Silver is being purified. So this is called cupellation process. This is called what? Cupellation process. Please note down this sentence in your classwork. Next continuation. Ultra pure sample of titanium is obtained by, this already we know, ultra pure metals have been refined by Van Alken method. In this, what happens? Titanium is treated with iodine at at low temperature. On heating, it forms titanium iodide. Titanium iodide, which on heating at 59 degrees C at a very high temperature is called volatile stable compound. Volatile stable compound. This volatile stable compound is being converted into titanium pure metal plus 2 moles of iodine again. Iodine vapors. So this is nothing but Van Alken method. So answer is what? Van Alken method. You can just check it out. So answer is C. So ultra pure metals like titanium, not only titanium, it can be purified even by zirconium also. Zirconium also is purified by Van Alken method. So titanium and zirconium can be purified by using Van Alken method. In this method, the metal is treated with iodine at high temperature, around 800 degrees C. So you can take approximately. So this it forms, which results in the formation of volatile stable compound, that is titanium iodide or zirconium iodide, and this are heating at a temperature of 559 degrees C changes to pure metal and impurities will be removed off. So this is nothing but along with iodine, the impurities present in the sample of titanium or zirconium are removed. So this is called Van Alken method. Very, very important. Please note it down. Next question. Zone refining is used for, so what is the process for which zone refining? Zone refining, as we already know, it is also called as fractional crystallization. Zone refining is also called as fractional crystallization. And what is this method is nothing but fractional crystallization zone refining. So this method is based on the principle that impurities are more soluble. impurities impurities are more soluble. Impurities are more soluble in the melt than in the metal. In the melt than the solid state of the metal. Than in the solid state of metal. Solid state of metal. So this is called zone refining. Is called what? Principle of zone refining. Impurities are more soluble in the melt than in the solid state of the metal. So that is called zone refining. It is also called as fractional crystallization. Which type of element? Silicon, germanium, gallium, which are used as semiconductors, and boron, indium. So boron, indium are refined by this process. So answer is silicon, germanium, and gallium. So all the three, fourth option D. So, which type of metals can be purified by using this zone refining? Elements like such as silicon, germanium, gallium, indium, boron. All these are refined by using these methods. Highly pure metals are obtained in this process. So this is called fractional crystallization and also called as zone refining. Next continuation. Nickel is purified by thermal decomposition of its Nickel is purified by the thermal decomposition of its hydride, chloride, carbonyl, and iodide. So this is nothing but what? Simple, it is Mond's process. So it is nothing but carbonyl. What is this called? Mond's process. In this process, what we'll do? Mond's process. In this process, what we'll do? Nickel is treated with carbon monoxide. It forms nickel carbonyl compound. Nickel carbonyl compound. So this is nothing but nickel carbonyl compound. It is at 332 350 kelvins, and this nickel carbonyl compound on heating at a temperature of 450 to 470 kelvins, 450 to 470 kelvins, it forms nickel, pure nickel plus 4 moles of carbon monoxide. So nickel is purified by thermal decomposition of its carbonyl compound, and in this the oxygen state of nickel is 0. The oxygen state of nickel is what? 0. Again, I'll write if you are getting confused. The oxygen state of nickel in nickel carbonyl is 0. That point also they may ask in the examination. The oxygen state of nickel in nickel carbonyl is 0. So please note down these questions. The answer solution. So answer is what? It is nothing but option C. So the process is called what? Mond's process. It is nothing but what? Mond's process. Very, very important. Next question. The process of changing the metal or ore into solution by the action of suitable chemical reagent and then precipitating the metal using a suitable precipitating agent is known as. The process of changing the metal ore into solution by the action of suitable chemical reagent and then precipitating the metal using a suitable precipitating agent is known as electrometallurgy, hydrometallurgy, pyrometallurgy, and electrorefining. So what you can understand by this? Changing the metal or ore into solution by the action of suitable chemical reagent. So it is nothing but based on property of wettability. So it is nothing but what? Hydrometallurgy. It is nothing but what? Since it is based on wettability. Wettability means the ore is wetted. So that is nothing but by using hydrometallurgy. Very, very important this question also. Next question. Identity M. Identify actually. It should not be identity. It should be identify. This T is removed and replaced with F. So identify M in the chemical equation. 4 moles of metal and 8 moles of cyanide ion combines with 2 H2 and O2. It forms 4 moles of metal cyanide ion plus 4 OH minus. So the metal could be, already you know this process is called as leaching. What is this process? Is called leaching. And leaching process is used for silver, gold, etc. So in this copper, irons, gold and zinc is there. So in place of M, definitely you'll get gold. So answer is C. Answer is what? It is nothing but C. As I told you, silver and gold are being concentrated by the use of leaching method. Leaching is a process in which a suitable reagent is added so that the metal is dissolved in it. A suitable reagent, that is sodium cyanide, is added to the metal so that the metal is soluble in sodium cyanide and forms metal sodium cyanide. So this is nothing but M is called what? Gold. It is nothing but, and gold and silver are being used in this process. Next continuation. For preparing ultra pure metals like zirconium, it is first converted into its volatile compound by treating with X, that is nothing but iodine. And this compound is decomposed by heating to some higher temperature. X is called. Directly you can say it is nothing but what? Iodine. It's simple, because zirconium combines with iodine, 2 moles of iodine, and forms zirconium iodide, volatile compound. This on heating at 59 degrees C, it forms zirconium pure metal plus 2 moles of iodine. So this is called Van Arkel method. Since already we know, it's nothing but what? It is Van Arkel method. So the compound is treated with X. Zirconium is treated with X. That X is nothing but iodine. Next continuation. Malachite is a basic copper carbonate, which is the only other element that can form basic carbonate ore. So malachite is nothing but what? It is a basic carbonate. It's nothing but calcium carbonate. Sorry, um, yes, copper carbonate along with magnesium carbonate. It is nothing but what? Malachite. So the only which is the element that can form basic carbonate ore is bismuth. So answer is what? C option. Answer is C. So that's why I told you O's formulas are also very important. Next, gold is extracted by hydrometallurgical process based on its property of being electropositive, being less reactive, to form salts which are water soluble, to form complexes which are water soluble. So gold has a tendency to form complexes which are water soluble because gold is combined with Au is combined with silver cyanide, sorry, sodium cyanide, along with water, along with oxygen. Then it forms what? It forms sodium, gold, cyanide taken 4 times. So this is nothing but what? Complex compounds. So gold has a tendency to form, based on property, to form complexes which are water soluble. This complex is water soluble, and this process is called as leaching. What is this process called as leaching? As I told you, leaching, fourth flotation in the methods of extraction of ores are very, very important. So answer is what? D, to form complexes which are water soluble. So this chapter definitely you'll get a question, and all the questions will be based on theoretical. Some numericals also might be coming based on a link diagram. That questions also we have discussed, and more questions we'll discuss now. So please concentrate what we are discussing. This is more than enough for JEE Mains and NEET and advanced level. Next continuation. So some more additional questions I'll add for this. Tough questions will go based on this, so that we can wind up this session, and we can start new chapter in the next session. Now, question number 14. Let us see now. Consider the following reaction. Consider the following reaction. At 1000 degrees C, zinc solid plus half O2 gas comes together to form zinc oxide solid. Delta G, that is standard Fahrenheit change for this reaction, is equal to minus 360 kilojoules per mole. Minus 360 kilojoules per mole. Next continuation. Carbon plus half moles of oxygen, carbon solid, half mole of oxygen gas combines together to form carbon monoxide gas. Delta G decrease, that is gives free energy, is standard free energy change is equal to minus 460 kilojoules per mole. Minus 460 kilojoules per mole is given. Choose the correct statement. Choose the correct statement. This question is very, very important, this model. So please note down. Choose the correct statement. Option A, zinc can be easily oxidized. Zinc can be oxidized by carbon monoxide. Option B, zinc can be easily reduced by zinc oxide. Zinc oxide can be reduced by graphite. Option C, both A and B are true. Both A and B are true. Option D, both A and B are false. A and B, both A and B are false. So the right answer for this we have to discuss now. So the delta G values they are given so that you can understand which can reduce what. So delta G for the formation of zinc oxide is given as delta G for the formation of zinc oxide is given as minus 360 kilojoules per mole, and delta G for the formation of carbon monoxide is given as minus 460 kilojoules per mole. If we see the same thing in Ellingham diagram, we can understand that carbon can reduce easily zinc oxide to zinc. So answer is zinc oxide can be reduced by graphite, that is carbon. So answer for this is zinc oxide can be reduced by graphite, because zinc oxide plus carbon gives us to zinc plus carbon monoxide. Zinc oxide plus carbon gives rise to zinc plus carbon monoxide. So this is nothing but based on the Ellingham diagram. If you the standard free energy change is more in the sense without minus sign. If you take only minus sign is only if you consider just if you neglect this minus sign 360 and 460. So the 460 can be solved 361. So answer is what? Zinc plus carbon monoxide. So next question. Question number 15 now. So the previous question is very, very important. Next, which are the following reactions? Which of the following reactions? Which are the following reactions is an example of auto reduction? Option A, Fe3O4, that is magnetite ore, plus 4 moles of carbon monoxide gives rise to 3Fe, 3 moles of iron, plus 4 moles of carbon dioxide. Next, option B, cuprous oxide plus C, carbon gives us to 2 moles of copper plus 1 mole of carbon monoxide. Option C, Cu plus 2 plus Fe, solid. This is aqueous, this is solid. Gives rise to Cu solid plus Fe plus 2, aqueous. So iron is displacing copper. Next, option D, Cu2O plus half Cu2S. It forms 3 moles of copper plus half moles of sulfur dioxide. So in the first case, if you see, so which of the following reactions is an example for auto reduction? What is auto reduction? Auto reduction is self-reduction. Self-reduction means same element will undergo reduction by itself. So here we can see In the first case, carbon monoxide is reducing agent. Second case, carbon is reducing agent. Third case, iron is reducing agent. And fourth case, copper itself undergoes reduction. So answer is fourth option. In this reaction, copper undergoes self-reduction. So answer is what? Fourth option. This is cuprous oxide combines with cuprous sulfate and forms copper and sulfur dioxide. So here sulfur and oxygen are combining and copper is coming out. So this is nothing but what? Self-reduction. So because this cuprous oxide is reduced by cuprous sulfate. So it is nothing but what? Same metal is involved in both the cases. So it is called as self-reduction. It is called what? Self-reduction. Next question number 16. Next question number 16, very, very important. This is also addition of of high proportion of manganese, high proportion of manganese makes steel useful in making drives of trial loads, comma, because manganese option A gives hardness to steel. Steel is an alloy of iron, manganese, carbon. So option A gives hardness to steel. Option B helps the formation of oxides, the formation helps the formation of oxides of iron, oxides of iron. Option C can remove oxygen only, can remove oxygen only. And option D can show highest oxygen state of +7, can show highest oxidation state. This point is very, very important. Why manganese is added in the steel? So oxygen state of +7. So what is the answer might be? This we have discussed in the lecture also. Please try to recollect now. Then you answer it. Meanwhile, I'll write the answer now. So it is nothing but, as we already know, stainless steel contains what? Steel is an alloy by the means of iron, manganese, copper, etc. So manganese is added to steel because it gives hardness to steel. It gives what? Hardness to steel. Very, very important. So manganese gives hardness to steel. That's why addition of high proportion of manganese makes steel useful in making rails of rail loads. Since rail loads should be very hard, so since if you add more amount of manganese, high proportion of manganese, it gives hardness to steel. So this question is very, very important. General question. Next question number 17. Brine is electrolyzed. Brine is electrolyzed using electrolyzed by using inert electrodes. The reaction at anode is the reaction at anode is option A, chlorine minus aqueous, uses to half Cl2, that is gas, plus electron. EDG of cell is equal to, that is electrode potential of the cell is equal to 1.36 volts. Option B, 2 moles of water, liquid state, changes to oxygen gas plus 4H plus 4 electrons. EDG of cell is equal to 1.23 volts. Option C, Na plus sodium ion plus 1 electron gaining. It forms sodium solid. EDG cell is equal to 2.71 volts. Option D, H plus aqueous plus electron gives rise to half mole of hydrogen gas. EDG of cell is equal to, that is electrode potential of the cell is equal to 0.00 volts. So anyway, the brine solution is electrolyzed by using inert electrodes. The reaction at anode. Anode means definitely there is no possibility of sodium and hydrogen gas because these are gaining of electrons, because at anode reduction takes place. What is taking place? Sorry, at anode, what is taking place? Oxidation taking place. Always at anode, oxidation taking place. Oxidation takes place. So oxidation means losing of electrons, losing of electrons. So losing of electron means that said if you send it, it will become positive. So only A and B is the right option for oxidation, only because C and D are nothing but gaining of electrons. So this C and D are reduction. So answer could be A and B. And in the already brine solution nothing but NaCl. Brine solution nothing but what? NaCl. So by the electrons of sodium chloride, we'll get chlorine gas at anode. Chlorine gas at anode. So answer is first option. Answer is what? It is first option. Chlorine gas is formed at anode. These values simply they are given. So, but the main concept is at anode always oxidation takes place. So oxidation means losing of electrons. So losing of electrons, if you are at this side, it becomes minus. So if you are sending that side, it becomes plus. So only the anode reaction can be A and B based on this question. But anyway, brine solution is nothing but sodium chloride. So sodium chloride means chlorine gas is formed at anode. So answer is 100%. It is first option. That is 17th one question. Answer option is A. I hope it is clear. So please note down this question in your classwork. Next question. Next question. Question number 18. Roasted ore. Next question. Yes, question number I have written. Roasted ore. Roasted gold ore, sorry. Roasted gold ore plus cyanide ion plus H2O gives rise to compound X. Complex compound X plus OH minus. This X combines with zinc and forms Y plus gold. So option A, X is equal to AuCN2 and Y is equal to ZnCN taken 4 times minus 2. Next, option B, X is equal to AuCN taken 4 times 3 minus and y is equal to Zn Cn taken 4 times. That's why you should remember the charge is also very important. 3 minus. Next option C, x is equal to AuCn taken twice minus charge and y is equal to Zn Cn taken 6 times. That is zinc cyanide taken 6 times. Charge is how much? It is given as 4 minus. And last option, option D, x is equal to AuCn taken 4 times 3 minus and y is equal to Zn Cn taken 6 times 2 minus. So even you should know the valency of the metals also. That's why it is very, very important. So roasted gold ore. So already we know it is roasted gold ore plus cyanide plus water. It is nothing but what process? It is nothing but what? It is leaching process. Is what? Leaching process. And in leaching process, gold is treated with sodium cyanide along with water and oxygen gas. So due to which what happens? It forms a complex compound called gold cyanide and zinc cyanide taken 4 times 2 minus. So option is A. Sorry. Next question. So please copy down. These type of questions are very, very important. Next question we are doing now. Match the conversions in column 1 with the type of reactions given in column 2 with the type of reactions given in column 2. So here I write column 1 and column 2. This question is also very, very important. Question number 19, column 2. Option A, lead sulfide changes to lead oxide. And here P, it is roasting. Option B, calcium carbonate changes to calcium oxide. Q, it is calcination. Option C, zinc sulfide changes to zinc. R, carbon reduction. Option D, cupous sulfide changes to copper. Yes, it is self-reduction. It's a very, very typical question. Please note it down. Next is a multiple choice question. Option A now. A is Q, comma. B is R. C is P, comma R. And D is P, comma S. Is option 1. Next option B. A is P. B is equal to Q. D is what? Q. C is P, comma R. They have given multiple options for C and D. D is equal to P comma S. Next, third option, A is PS, A is P comma S. Next, B is Q, B is what? It is Q. C is equal to P and D is equal to S. Now option D, A is P comma S, B is equal to PQ, C is equal to P and D is equal to S. So these are the four options that given: A, B, and C and D. A, B, C, and D. So this type of questions are very important. Matrix match questions. So multiple answers you'll get for one option only. So let us see now. Let us see now. Yeah. Lead changes to lead sulfate changes to lead oxide. Calcium carbonate changes to calcium oxide. Zinc sulfate changes to zinc. Copper sulfate changes to copper. So already we know copper is undergoing self reduction. So D should be definitely yes, and D should be definitely yes. And apart from the directly, it cannot change to cuprous oxides. First, it should go for P and roasting and self reduction. So for D, we'll get P and yes. And A, lead sulfate changes to lead oxide. It is nothing but A is P, that is roasting, because in roasting only we can convert sulfide over to oxide ore. And next is B is Q. Calcium carbonate on heating changes to calcium oxide. It is nothing but on heating. It is nothing but simply directly we can say calcination. And C is zinc sulfate changes to zinc. First it should go for roasting, then it converts into zinc oxide. And this zinc oxide is being reduced by carbon. So C is what? P comma R, because zinc sulfate on roasting gives zinc oxide. Zinc oxide changes to with carbon, it forms zinc. So carbon reduction. So answer is second option, that is A is P, B is Q, C is PR, and D is PS. So please note down, these type of questions are very, very important. So A is P, B is Q, C is PR, D is PS. So this is called matrix match question. Very, very important. Please note down in your classwork. So next question now. So from this chapter, match the following is very, very important. So how many maximum match the following questions you have to do so that it will be easy for you. Next question. Question number 20. Again, I'll give one more match the column. So match the following column 1 with column 2. Match the following. Column 1 and column 2. First one, cyanide process. In this, A, extraction of aluminium, extraction of aluminium. Next, second one, self-reduction, self-reduction. Option B, extraction of silver, extraction of silver. If you're confusing with the symbol, aluminium ion, right? Next, third process, electrolytic reduction. Electrolytic reduction. This question is very, very easy, but it's more important also. Electrolytic reduction. Option C, extraction of copper, extraction of copper. And option 4, carbon reduction This is only one-to-one answer. Extraction of tin. Extraction of tin. For this question, as this is a lengthy question, I cannot give options, so directly I'll discuss the answer. So cyanide process, which metal is being extracted, self-reduction process, which metal is being extracted, and this one, electrolyte reduction, which metal is being extracted, which metal is being extracted, and next we have carbon reduction, which metal is being extracted. So the answer is now cyanide process. We already know it is nothing but extraction of silver. So first one is B. First one is B. Second one, that is C, because self-reduction, extraction of copper. Third one, A, because electrolyte reduction, we already know extraction of alumina, this cryolyte and fluorspar is added. So electrolytic reduction, it is used for extraction of aluminum. So third one is A. And fourth one, carbon reduction is nothing but what is left over now, BCA. So it is nothing but extraction of tin. So answer is BCAD. BCAD. This is the answer I am writing here directly without any options, since it is lengthy question. So with this, we have completed this chapter. So many questions we have discussed. Now I'll write summary of the chapter. So please note down in this chapter we have to do based on this. Now I'll write summary of the chapter, what to concentrate in this chapter, summary of the chapter, so that we can end up this session. So summary of the chapter now. First we have what? Methods in the extraction of metals. From their ores. From their ores. Second we have Ellingham diagram. Ellingham diagram. Third we have extraction of metals like iron, copper, zinc, aluminium, tin. So in iron, copper, zinc, aluminium, tin. So these are the extractions we have. And fourth one we have what we have in this chapter now, various refining methods, refining of metals, and alloys, formulas of ores. You can write even alloys also. Alloys. So these are the four topics we have. So first topic is most important. Second topic is also most important. Third one is most important. So these three topics are very, very important. So usually you get questions from these three topics only for the entrance exam. So you concentrate more on these three topics, and in this topic, if you concentrate, it's okay. But these three are compulsory. First, second, and third are compulsory, so that you can get easily one question from this, one or two questions for NEET as well as JEE Mains. So you do more questions on this based on these three topics in JEE material or any other competitive material or entrance books. So easily you can get grip on the subject. So with this, I'm ending this session. And this chapter is finished. So easily you'll get 2-3 questions from this chapter. So please do accordingly what we have discussed in all the 6 lectures. So this chapter is totally, we have completed in 6 lectures. So I hope you will utilize the best use of it. Thank you all.